Alright, so I'm going to look at determining displacement. And just like we did the story problems where we had a bug going from the 6 centimeter line to the 3 centimeter line, or those ones where we had pictures where you had a number line and you had to look at them, we're going to do the same thing, but we're going to get information off a graph. And first things, just remember, displacement is just from start to end, initial position to final position only, regardless of all the information, like all the back turns in between. So if you start here and end there, that's what you're measuring. Positive displacement, you're going to get positive and negative answers. Positive displacement will be things for like east and north, right and up. You get negative displacement if it's left and down or west and south. Also, too, on a graph, a positive slope, if it's sloping up from start to finish, will be a positive displacement, and if it's sloping down from start to finish, it should correspond with the negative. So the symbols we use, mostly in our class, we use delta x, which is called the change in position. You can use change in distance or change in y for vertical. So when we take these equations, I'm sticking with the change in x. You subtract the final minus initial. It's chronological. The last spot reached minus the first spot reached. And it is found on the y-axis, which is kind of crazy because we call it displacement because we're talking about horizontal motion. But when we put it on a position time graph, all of a sudden, our time becomes our x-axis and our y-axis becomes our change in position, which is the symbol x. It's a vector, it has magnitude and direction. It can be positive or negative, and it's usually measured in meters, but we can have any unit to work with. And it can be the same as distance, which we're not going to do today, but we had those problems where if it's traveling a straight line, the distance and displacement are the same, and distance is just the absolute value. So here's an example. From 1 to, oops, ignore that little typo there, 1 to 4 seconds, what's the object's displacement? So you got to look at 1 second and read over and see that it was at 1 meter. Then you go to 4 seconds and do the same thing. And it's not here, so I'm just going to draw that on here. That you have 4 seconds. There it is. And you'll see that's at 4 meters. So we're looking at 4 meters and 1 meters. You got to figure out which one's your initial. Your initial is the one that happened at 1 second, so I'm going to call that initial. And my final is the one that happened at 4 seconds. That's my final. So it's 4 minus 1. And I get 3 meters is my displacement. And it's actually positive 3. And if I look at my graph, it's sloping up, which should correspond. Right, from 0 to 250 seconds. So here's my 0 seconds. It's covered up there a little bit. Here's my 250 seconds. So I'm going to go up to 0 seconds and read over and say negative 10 meters. That is my initial displacement. Then I'm going to go to my last time, which is 250 seconds, and I read over and it's negative 30 meters. So that is my final position. So remember the formula, change in position or displacement is negative 30 meters, which is my final, minus initial, I'm just going to write it up top so I get the order right, minus negative 10, right? So that's a minus negative 10 there. I'm running out of room. These are all meters. So negative 30 minus negative 10 is the same as negative 30 plus 10, and they're both meters. Negative 30 plus 10 is negative 20 meters. Now, when I look at this, I have a line that's going up and a line that's going down. So what should my slope be? Well, look where you start at, look where you end at, and if I draw an arrow from start to finish, notice which direction my arrow takes. It is a downward or a negative slope, which corresponds with a negative displacement. Good luck with that, and if you have any questions, please let me know.